Here's what most engineers believe about cloud provisioning. You make a request. The cloud processes it. The resource appears. It's ready. You move on. And honestly, that belief is completely reasonable. It matches everything the API tells you. You call create instance. You get back an instance ID and a 200. You apply a Terraform plan. It says apply complete. Resources 3 added. You run a Kubernetes deployment. Qtld says deployment created. The language of every tool in the ecosystem is the language of completion. Past tense, done. So the belief makes sense. It's the conclusion the tooling explicitly invites you to draw. It's also wrong in a specific way that causes a specific class of production incident, one that is particularly hard to diagnose because it looks, from every dashboard you're watching, like something entirely different. By the end of this video, you'll understand exactly what provisioned actually means, why it's a fundamentally different state from ready, and most importantly, why the gap between those two states is where a class of failures hides that almost no team catches before it bites them. Let me show you the crack in the belief with a single observation. You've just launched an EC2 instance. The API returned a 200 with an instance ID. From the API's perspective, the instance exists. From your perspective, based on everything the API told you, the instance is ready. Now try to SSH into it. In most cases, you can't, not yet. The instance is in a pending state, which means the hypervisor is allocating resources, the OS is booting, the network interfaces are being configured, the user data script is running. All of this takes time, sometimes 30 seconds, sometimes 3 minutes, sometimes longer, depending on the instance type, the region, the AMI, and the current load on the availability zone's provisioning infrastructure. The API didn't lie to you. The instance exists. Create instance did what it promised. It created the instance. What it didn't promise, and what most engineers assume without noticing they're assuming it, is that created and ready to accept connections are the same moment. They're not. There is a period of time, variable, unpredictable, dependent on factors you don't control and can't query, during which the instance exists and is not ready. That gap has a name, and understanding what actually happens inside it changes how you design every system that involves cloud infrastructure. Provisioning is not a single event, it's a state machine, a sequence of distinct states that a resource moves through, each with its own conditions for advancement, its own failure modes, and its own meaning. For most cloud resources, that state machine has at least 5 states that matter, and provisioned, in the sense the API uses, is not the last one. State 1 is requested. The API has received your call, the request is in a queue, nothing has happened yet on any physical infrastructure. The 200 you received confirms this state, not any state beyond it. State 2 is allocating. The cloud's internal scheduler is finding capacity. For common instance types in popular regions, this is fast, milliseconds. For large instances, GPU instances, instances with specific placement requirements, or instances in regions under capacity pressure, this can take minutes, or fail. The insufficient capacity error lives here, and it's one of the most confusing errors in cloud computing, because it arrives long after the initial 200 that suggested everything was fine. State 3 is provisioning. Resources have been allocated. The hypervisor is setting up the virtual machine. The OS is booting. Block storage is being attached. Network interfaces are being configured. Your user data script, if you have one, is running. This is the state EC2 calls pending. It's the state where your instance exists. The API returns data about it, and it cannot yet do anything useful. State 4 is available. The resource has reached the state it was designed to be in. For an EC2 instance, this is running. The OS is up, the network is configured, the instance is reachable. But available doesn't mean ready for your application. It means ready for the platform. Your application might still be starting. Your configuration management tool might not have run yet. Your health check endpoints might not be responding. The dependencies your application needs might not be reachable. State 5 is ready. This is the state that matters to your users, the state where the resource is correctly configured, your application is running, your dependencies are reachable, and the system can serve traffic. This state is never reported by the Cloud API Because the Cloud API has no idea what ready means for your specific application. Only you know that. Only your health checks, your smoke tests, your post-deployment verification can confirm it. The API tells you about states 1 through 4. State 5 is your responsibility to define and verify. Most deployment pipelines stop checking at state 4. They see running and move on. The gap between running and ready is where the incident lives. Earlier, I said this wrong belief causes a specific class of production incident that's hard to diagnose. Here's why. When a resource is in state 4, available but not yet ready, it will often pass the checks that deployment pipelines perform. The instance is running. The health check endpoint returns a 200. The load balancer registers it as healthy. Traffic starts arriving, and some of that traffic fails. Not all of it. Not in an obvious pattern. The failures are intermittent. Some requests succeed, some fail. The error rate is elevated but not alarming. The P99 latency is high but not catastrophic. Your dashboards show a system that is degraded, not broken. What's actually happening is that some requests are landing on instances that haven't finished starting. The application process is running, but the warm-up isn't complete. The local cache hasn't been populated. The database connection pool hasn't been established. The configuration hasn't been fully loaded. The instances are in state 4, they're not in state 5, and nothing in your infrastructure told you there was a difference. This pattern has a specific name in distributed systems: premature traffic admission. And it's caused almost entirely by treating the cloud's definition of available as equivalent to your application's definition of ready. The fix is not complicated. Proper readiness probes, meaningful health check endpoints that verify application state, not just process existence, deployment strategies that gate traffic behind actual readiness confirmation. But you can only implement the fix once you understand that the gap exists and that closing it is your responsibility, not the platform's. When you internalize that provisioning is a state machine and provisioned is not the final state, 3 things change concretely. The first is how you write health checks. A health check that returns 200 because the HTTP server is listening is not a readiness check. A readiness check confirms that the application can serve its intended traffic, that its dependencies are reachable, its cache is warm, its connection pools are established, its configuration is loaded. These are different checks. Most teams implement the first and call it done. The second is how you design deployment pipelines. A pipeline that proceeds to the next stage when instances reach state 4, running, is not verifying readiness. A pipeline that proceeds only when a configurable number of instances have passed a meaningful readiness check, for a configurable duration, is implementing state 5 confirmation. The difference in production stability between these two approaches is significant and almost entirely invisible in staging environments, where the gaps between states are smaller and the traffic that exposes them doesn't exist. The third is how you think about rollbacks. A rollback that terminates new instances and redirects traffic to old ones assumes the old instances are in state 5. If the rollback is triggered during a deployment where old instances have been draining connections, or if the rollback itself involves reprovisioning, you've returned to the state machine. The rollback is a provisioning operation. It has the same states. It can fail at the same points. The Cloud API is honest with you. When it says created, it means the resource exists. When it says running, it means the platform considers it available. It does not say ready, because it cannot say ready. It has no knowledge of what ready means for your application. The gap between available and ready is not a flaw in the platform. It's a boundary. The platform's responsibility ends at state 4. State 5 is yours. Most incidents that look like deployment failures, intermittent errors after a release, or mysterious degradation following a scale-out event are not infrastructure failures. They're state machine failures. The assumption that state 4 and state 5 are the same moment applied to a system where they reliably are not. Provisioned is not ready. The API tells you when the first is true. Only you can define when the second is.